In this lesson, we will define rational exponents. Let's quickly understand what the lesson will cover. So far this year, anytime I have used an exponential notation, I have always assumed that my exponent was a positive natural number. In this lesson, we're going to expand the set of exponent to rational number. We will see what it means. In the first part of the lesson, I will define 8 to the 1/3, or 25 to the 1/2, or negative 32 to the 1/5. We'll understand what these numbers mean. So in the first part of the lesson, the numerators will always be 1. And then we will look at numbers like 8 to the 2/3, or 25 to the 5/2, or negative 32 to the 6/5. So then we'll change our numerator to something different than 1. And at the end of the lesson, we will have understood the meaning of a to the p over q. Please make sure you understand that all our exponent will be positive, okay? We will see in the next lesson what it means to have a negative exponent. In order to master the content of this lesson, you will need to be familiar with evaluating the nth root of a real number. That was the content of the previous lesson. You will also need to be familiar with the properties of exponent. So before we define the meaning of a to the 1 over n, let's understand the reason behind the definition. So let me first look at the number 8 to the 1/3. I have no idea what this number means, what this writing means. I see right here the base is 8 and the exponent, the new exponent, is 1/3, but I don't know how to understand this exponent right here, okay? Well, this is a number. I'm trying to figure out what it is. It is a number. What I can do to any number is raise them to any power I want. So I'm going to take this number and I'm going to raise it to the power of 3. Now, what's important when we extend the set of the exponent is that we keep the property of exponent. We want this property to be the same, to remain unchanged. Now, what did we have before when we had a to the x to the y? Well, we know that the property of exponent is telling us to do a to the x times y. And this rule, I want it to be unchanged if x and y are natural number or positive rational number, okay? So right here, 8 to the 1/3 to the power of 3, I want that to be equal to 8 to the 1/3 times 3. Now, what is 1/3 times 3? It is a 1, and 8 to the first power is 8. Okay, so what happened there? There was a number. I didn't know what it was, right? We could have called it a right here. A equals a to the 1/3. I took this number and I raised it to the power of 3 and now found 8. Now, I know what this number is. By definition, a is the cube root of 8, right? A cube equals 8, so a is a cube root of 8 by definition. The inverse of the monomial f of x equals x cubed, right? The cube root. So by doing this, it seems that I have given meaning to this notation. 8 to the 1/3 stands for the cube root of 8. Okay, let's go over a second example, just like this one, to make sure we are on the right track. All right, let me look now at 25 to the 1/2. Let me call this number a. Again, what I'm trying to do right here is to find a meaning to that. I don't know what this number may mean, okay? So I'm going to take a and I'm going to square it. All right, so if we square a, what do we have? 25 to the 1/2 squared. And again, I want to have this property true even when I change my exponents to 1/2 or 1/3 or whatever. I want this property to be true. So 25 to the 1/2 times 2 is 25 to the first power. So this is just 25. Okay, so what happened there? I squared a and I found 25. So a is a square root of 25. Now, I'm going to assume this is a non-negative number. I'm going to assume this is a non-negative number. And so it would be the positive square root, the principal square root of 25. So it looks like 25 to the 1/2 should be the square root, principal square root of 25. All right, let's now look at the defining statement for a to the 1 over q. So following what I just said, it makes sense to define a to the 1 over q to be the qth root of a. This is the index of a root. And the reason behind this definition is that we want to keep this property of exponent true, okay? We don't want this property to change. All right, let's go over a couple of examples that will clarify this statement. All right, I have to rewrite with a radical and evaluate when possible. Remember, a to the 1 over q means the qth root of a. That's it. All right, so 8 to the 1/3 by definition, it means the cube root of 8. Do I know the cube root of 8? Yes, it is 2. Next example. All right, two examples here. 81 to the 1/4. So by definition, that means the fourth root of 81. What number raised to the power of 4 gives you 81? Well, you should know that 3 to the power of 4 is 81. So this is just 3. Now, negative 27 to the 1/3 means the cube root of negative 27. Which number raised to the power of 3 gives negative 27? That's just negative 3. You see, it is not difficult. You just need to remember that a to the 1 over q is the qth root of a. That's it. Next examples. Be careful with number 4. This is something we worked on at the beginning of the year. What is the base of the power 1/2? The base is just the number written right before it. That's 16, not negative 16, okay? The negative is not in the base right here. So basically, that means the opposite of 16 to the 1/2. Again, what is a power 1/2? Well, power 1/2 means the square root. Now we usually don't write 2 right here, right? We don't write it. We just say negative square root of 16. Negative square root of 16. The square root of 16 is 4. So this is negative 4. Okay? On the other hand, right here, the negative is inside the base now, right? Because the power applies to the parenthesis, okay? So the negative is inside the base. So again, this is a square root of negative 16. Again, I don't write the 2 right here, but here I know that the square root of negative 16 is not a real number. I cannot have a negative number inside the square root if I work with real numbers only. Okay? All right, next example. So right here I have a fourth root, right? This is a fourth root of what? Of negative 16. Here again, if you remember what we said in the lesson yesterday, if n is even, right, this is an even indexed root, you can't have a negative number inside, right? I mean, you cannot find a number so that when you raise it to the power of 4, you find negative 16. This is not going to be a real number. It's not going to be a real number. So this is not a real number. It's not defined as a real number. I'm going to let you do number 7 on your own. Let's look at the next series of example. So in the next series of example, I'm going in the other directions. I am given an nth root and I want to write it as a fractional exponent, a rational exponent, same thing. All right, so the fourth root of x is just x to the 1/4. All right, see, pretty simple. Next one. Ooh, we have a couple of roots here. So the first one I'm going to rewrite as a rational exponent, is the one inside. This is a square root of x. Again, I don't write the 2 right here, right? But that means x to the 1/2. All right, now, what do we do here? We take the cube root of this. Now, this cube root, you write it as power 1/3. So it's x to the 1/2 to the 1/3. And what do you do when you have exponents like that? You multiply them. 1/2 times 1/3, which is x to the 1/6. That's it. This is just x to the 1/6. I am not asked, but I could rewrite that as a root, as a radical notation, right? And it's a 6th root. And so I noticed that taking the cube root and then taking the square root should be the same as taking the 6th root. Next example. Okay, so that's pretty straightforward. The 5th root of x is the same as x to the 1/5. That's it. The square root of x is x to the 1/2. Okay, it is important that you be able to write any radical with a fractional exponent. That's what we're training here for. Okay, here again, a root inside a root right here. So what's inside? The square root of x. So that's x to the 1/2. And then outside that, I have another square root. So again, I got a raise to the power of 1/2. So 1/2 times 1/2 is x to the 1/4. That's it. Number 13 is a repeat. I just did it before. Let's move on. I'm going to let you do number 14. Let me go over number 15. So, okay, what's going on in number 15? In number 15, I have a 5th root right here. So a 5th root, I write that as a power 1/5. Now, what's under the radical? It's x cubed. So it's x cubed to the 1/5. Here, I have to apply the rule of exponent. 3 times 1/5. 3 times 1/5 is 3/5. So it's x to the 3/5. Next example. Well, here I see that the root is a cube root. Cube root means power 1/3. Okay. What am I taking the cube root of? x5. So this is x to the 5th inside. Now, rule of exponent, you got to multiply the exponent. 5 times 1/3 equals 5/3. So this is just x to the 5/3. Okay, let's now go over the full definition of a number to a rational exponent. Positive. Let's go over it. Okay, so if I take a number and I raise it to a rational exponent, let's say p over q. Now, p over q, I can always write it as p times 1 over q, right? Now, this is the same according to the rule of exponent. This is the same as e to the p to the power of 1 over q. And I know what to do with my 1 over q right here, right? 1 over q means the qth root. So I'm taking the qth root of ap. All right, so I gave a meaning to that. How so? Well, the cube root is defined as the inverse of a monomial of degree q, right? X to the q, and a to the p, I understand what it is. P is a natural number. So this is fully defined. So now I understand this notation. There is another way to understand that. I could have first, instead of writing p times 1 over q, I could have said, well, this is a to the 1 over q times p. It's the same thing, right? P times 1 over q or 1 over q times p. But when I write it like that, I land on a slightly different notation, a to the 1 over q to the p. So now the first thing I do here is I gotta take the qth root of a, and then I raise it to the 1 over p. So in this lesson, we will not look at the difference between these two notations because we will always assume that the qth root of a is a real number. It's always defined. Let's look at the defining statement of a to the p over q, and let's do the last set of examples. Here it is. I'm defining a to the p over q as the qth root of a to the power of p, or the qth root of a to the p. So the power of p sometimes is outside, sometimes inside. You choose which one you want to do first. Let me show you how it works. Okay, so in example 17, I have negative 27 to the 4/3, right? So I can look at it as negative 27 to the 4th to the 3rd, right? So in this case, I will take the cube root. 1/3 is a cube root after I raise negative 27 to the 4th. Now, I don't know about you, but personally, I don't know what negative 27 to the 4th is, right? So if I don't have a calculator, I'm stuck right here. Okay, let's look at the other way to do that. So instead of raising to the power of 4 first, I can take negative 27, raise it to the 1/3, and then raise that to the power of 4. It's the same, right? 4 times 1/3 or 1/3 times 4 is the same. So in this case, I would take the cube root first, cube root of negative 27, raised to the power of fourth. Now, the cube root of negative 27, I do know this one, right? What number raised to the power of 3 gives you negative 27? Well, that's just negative 3. And negative 3 to the fourth is just negative 3 times negative 3 times negative 3 times negative 3 is 81. So it was easier to first do the root and then raise to the power, okay? Let's go over the next example. Okay, I'm going to take the root first, right? So this is 16 to the 1/4, that's a root right here, to the power of 5. Now, what kind of root is it? It's a fourth root of 16 to the power of 5. The fourth root of 16 is 2, and 2 to the fifth power is 32. No need of a calculator here. Example 19, negative 25 to the 3/2. So this is negative 25. I'm going to do the root first to the 1/2. That's a root right here to the power of 3. So power 1/2 is a square root. So it's a square root of negative 25 to the power of 3. Now, square root of negative 25 is not a real number. So this is not going to be a real number, okay? You cannot have a negative inside a square root, or actually now we know that we cannot have a negative number inside an even index root, okay? If you take an even index root, a must be positive or equal to 0. This is something we've covered in yesterday's lesson. Let's move on. Okay, I'll do number 20. So I have 8 to the 4/3, so 4/3, that's 1/3 to the power of fourth. Power 1/3 means cube root. Cube root of 8 to the power of 4. What's a number so that when you raise it to the power of 3 you find 8? That's 2. 2 to the power of 4 is 16. I'm going to stop here. I'm going to let you do the last two examples. I hope this lesson was clear. Thank you for watching.